neutralization. So we expect that the neutralization reaction takes place first. And the neutralization reaction, you know, when a base reacts with an acid, it will produce a salt and water. Now, this salt here, this salt which is being produced, is the salt that we need in this equation. Hmm, interesting. Okay, so this salt which is being produced is the salt we need in this equation. So what do? We need to calculate that salt. Okay, so we need to carry out the calculations. We need to carry out the calculations to calculate the concentration of that salt. So, uh, 3.39 of potassium hydroxide, I calculated the number of moles of this potassium hydroxide which is being added, which is our base. So it's 3.39 over the MR. Number of moles is mass over the MR. So I calculated that, okay, potassium is 39 plus 16 plus 1. And then I found this number of moles when you calculate the number of moles of potassium hydroxide. Then, knowing that these are the number of moles of potassium hydroxide which were added, how much salt is produced? Well, since these guys they are actually monobasic, both of them, the number of moles of potassium hydroxide, okay, the number of moles of the base is equal to the number of moles of the salt. If you have to do like a full balance reaction, you'll find that like it's 1:1 here. So the number of moles of potassium hydroxide are equal to the number of moles of the salt. So now I have the number of moles of the salt. Now I'm looking for the concentration of the salt. Remember, concentration is number of moles over volume. But we were told here that the volume of the solution is constant. So the number of moles we have, now we just have to divide with what? With the volume. Number of moles over volume. So the concentration of the salt would be equal to 0.0605357 number of moles over the volume 0.25. Now I calculated that concentration. I calculated that concentration to be 0.2421. This one here. That's the concentration of the salt. So I have the concentration of the salt. Yay, I'm happy. Now, the concentration of the acid. Remember, in the beginning, we're given that there's 250 cubic centimeters of this much acid. But then during the neutralization reaction, some of the number of moles, some of the moles of some of the butanoic acid is being used to neutralize the base, but some will remain because in a buffer there's always a weak acid and the salt of the weak acid. So now some number of moles which is remaining, that is what we need to get. Okay, so we said we had this number of moles of potassium hydroxide. And in the beginning, the number of moles of the acid, well, it's just straightforward. Number of moles of acid is what? Concentration times volume. So the number of moles of the acid is just concentration times volume. So the number of moles of the acid in the beginning is equal to, is equal to concentration times volume, CV, which is equal to 0.25, that's the volume. The concentration is 0.375, 0.376, I mean. And then when you calculate that number, the number of moles in the beginning, you find them that the number of moles of butanoic acid in the beginning was 0.094 moles in the beginning. So what about in the end? How many were there in the end? How many were there in the end? Well, we need to subtract those that were used, which are those of which is equal again to the number of moles of the base, because it's 1:1 as well. So then the number of moles again is 0.06 minus 0.06 0.05357. So now I have the number of moles of the remaining number of moles of the acid. When you do the subtraction, you get 0.3, 0.03, 0.033464. So these are the number of moles of the acid which are remaining. Now I need to calculate the concentration of the what? Of the acid. The new concentration of the acid. Because this one was the old one, 0.376. Some moles have been removed. And how many moles have been removed? 0.060. How do I know? Because those were the number of moles of the best that was added, and they are reacting in a ratio of 1:1. So okay, now I have 0.03364 moles of the acid remaining. To get the concentration, it's just number of moles, 0.033464. Number of moles over volume, again 0.25. Then you calculate the new concentration to be 0.133, 0.133. So now I have 0.133. That's the concentration of the acid. So I'm given the pH in the question. It's given as 5.07. Okay, now let me erase some of this stuff. It's getting messy out here. And I'm just going to restart the calcs. But okay. So remember, pH is equal to pKa. So pH is 5.07 is equal to pKa, which we don't know, plus the log of the concentration of the salt. We've calculated it here, 0.2421. The concentration of the acid, it's here, 0.133. Then we can calculate pKa by making pKa subject of the formula. So pKa is equal to 4.8126. And Ka would be equal to, remember, Ka is equal to 10 to the power of minus 4.8126. And then we can calculate Ka to be 1.53 times 10 to the power of minus 5. Yeah, okay, a buffer solution is a pH of 4.0. Why does this pH not change? Okay, I guess I'll leave that up to you. Okay, but yeah, that's the hard calculation. I don't know if I should say hard, but yeah. Hope that helps.